we can use definite integrals to find areas of planar regions. So if we consider this region R, and this blue function as f of x, and the other function as g of x, and we break this region up into infinitely thin rectangles which have a width of dx, then the height of each rectangle is f of x minus g of x. And we multiply this by dx, which gives us the area of that rectangle, and then we integrate from x equals a to x equals b, and that gives us the area of the region. Let's find the area of the region bounded by the curves y equals x squared and y equals x to 1/2 over the interval from 0 to 1. And we're asked to use rectangles that are perpendicular to the x-axis. So therefore the thickness of the rectangle is dx, and to obtain the height, the square root curve lies above the parabolic curve. So what we do is subtract x squared from x to 1/2 to get the height of that rectangle. And then summing up the areas of the rectangle from x equals 0 to 1 is effectively what this integral is doing. And that gives us the area of this entire region. And you can easily evaluate this integral. Find the area between the curve described by this function and the x-axis over the interval from 0 to 1. So the curve looks something like this, and it has a y-intercept of 1 and an x-intercept at 1. And what we do is divide this region from the interval 0 to 1 into vertical rectangles of thickness dx, and multiplying by the height of each rectangle gives us the area of one rectangle, and we integrate from 0 to 1, and that gives us the area of the region. So do the integration and post your answer in the comments.